Assalamualaikum warahmatullahi wabarakatuh. We are from Group 12. We'll talk about the ideal gas law and kinetic theory of gas. The members of this group are JANNAH binti ABDULLAH, Ardini binti AHMAD SHAHRUL Amin, and AMIRA FATINI binti AHMAD FATHILLAH.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Ardini, and today I would like to talk about the ideal gas law. So, ideal gas law obeys all the gas law which is involving pressure law, voice law, and Charles law. So, the equation of ideal gas law is PV equal to nRT. So, R is a constant of ideal gas law, and N is a number of mole. So the value of R, which is 8.314 joule per mole Kelvin. So ideal gas law states that the volume of a gas depends on pressure and temperature. So the equation of state is referring to the relationship between the volume, pressure, temperature, and mass of the gas. So ideal gas law is accurate as long as the pressure is not too high and temperature not too far from the boiling point. So here are all the lists of the gas law that involving in the ideal gas law.
The application ideal gas law in daily life. One of example of voice law is shrink. We all have seen a shrink while visiting a doctor. It is a medical device used to inject or withdraw fluid. It consists of a hollow cylinder called a barrel and a sliding plugger attached to it. The working principle of a shrink is like a reciprocating pump. When a plugger is pushed, the fluid will inject, and when the plugger is pulled, the fluid will withdraw. The pushing of plugger reduces the volume of the fluid in the barrel. This reduction in the volume causes a momentary increase in the pressure of the fluid, and the fluid is injected into the patient's body. In a similar way, the pulling of the plugger increases the volume of the fluid. It results a momentary decrease in a pressure of the fluid, and external fluid is withdrawn. The second one is Charles law. One of the example of Charles law is helium balloon. If you have had a chance to go out on a chilly day, you might have noticed that the balloon crumbles. However, if you take the balloon to a warm room, it will regain its shape. Why does this happen? This happens because the temperature on a cold day is low, and so the volume decreases. Now, in accordance with Charles' law, as soon as you enter a warm room, the temperature increases. With an increase in temperature, the volume also increases. Therefore, the balloon goes back to its original shapes. The last ideal gas law is pressure law, or as known as Gay-Lussac's law. One of its example is pressure cooker. The pressure cooker is a sealed utensil for cooking food under steam pressure. It is usually made up of steel or aluminium. When heat is supplied, the water inside the cooker vaporizes, and the steam is produced. The steam is periodically released through a valve to maintain the operating pressure inside the cooker. If the valve malfunctions and the heat flow is not interrupted, the pressure inside the cooker escalates. The increase in the pressure is due to Gay-Lussac's law. For example, the pressure of a fixed amount of gas increases with its temperature at constant value. This high pressure may rupture the cooker and may lead to an unfortunate accident.
So next is kinetic theory of gas. So in order to apply kinetic model of gases, there are 5 assumptions, which is gas are made up of particles with no defined volume but only mass. So gas particles have no intermolecular attraction or repulsion, which is total energy is equal to their kinetic energy. So gas particles move in a random motion. Collision between gas particles are completely elastic, which is no net loss or gain of kinetic energy when collision occur. So lastly is kinetic energy is proportional to the absolute temperature of gases. So here are the list of all the formulas that involved in the calculation of kinetic theory of gases.
The application in daily life for kinetic theory of gas is hot air balloon. So, Charles' law is the law that we apply in hot air balloon. So when hot air balloon is being heated, we'll see that the balloon expands. This is because when the molecules in hot air balloon is being heated, the gas will get energy and move faster. So this is also the reason why they collide with each other and with the wall of the balloon. So this is why the balloon expands when they are being heated. The next example of kinetic theory of gas that we can see in daily life is a kettle when it is boiling the water. So when the kettle boiling the water, the gas molecules in the kettle are also getting heat. So when the gas molecules get heat, they will receive energy, and this makes them move faster and also colliding everywhere. So this is how the gas molecules in the kettle are colliding with each other and also colliding with the wall of the kettle. So when they receive too much heat, receive too much energy, they will move too fast and then become too packed. So they will escape from the kettle through a tiny hole, and this situation is the cause of the whistle sound from the kettle when they almost finish boiling. Conclusion. So, as we know that ideal gas law is the combination of these 3 laws, which is pressure law, Charles' law, and Boyle's law, which is a special form of an equation of states. So from the equation shown in the slide, we can conclude that the average translational kinetic energy of the molecules in an ideal gas is directly proportional to the temperatures of the gas.
So that's all from us. Thank you.